Oh, sorry, I was muted all the time. So let's start the presentation. My name is Varga. I'm from the Budapest University of Technology and Economics in Hungary. Welcome. And anytime you have any questions in the presentation, there's a Q&A box. Please type it in, and every now and again I stop and check what's in this box. So try to answer, and I will answer at the end as well all these questions. So the presentation is about the Arrowhead Framework. It is industrial IoT solutions for heterogeneous ecosystems. So Arrowhead Framework has motivations from the industry, and the overview of this presentation is that I will talk about the system of systems, why interoperability, integrability, and independence is important, and how it is addressed by the Arrowhead Framework through service-oriented architecture. And because of the title of the presentation has the ecosystem word in it, so I will talk about industrial ecosystems in the value chain perspective and industrial ecosystems in the tool chain perspective as well. So both on the value chain, we have lots of players, and in the tool chain, how we develop things, how we operate things, how we maintain things. We have tools for that, and these tools need to talk to each other sometime, and hence this is an ecosystem as well. So Arrowhead, and actually Arrowhead Tools, addresses that as well. So I'm going to talk about some basic principles of Arrowhead, such as the local automation clouds or various multi-clouds on the edge, on the platform, on the enterprise level. And since Arrowhead is not only an interoperability framework, but an integrability framework, there are maturity levels for integrability. There are native Arrowhead capable systems. There are systems that need software adapters or hardware adapters to become Arrowhead capable. And there are some mandatory and supporting core systems in Arrowhead, and there is this engineering tool chain, which also a great ecosystem around the Arrowhead, and it helps from the requirements to the education and anything in between. Helps with tools around Arrowhead systems and services. And Arrowhead has become an Arrowhead project, so there are collaborations with other Eclipse projects. I will talk about that. At the moment, Arrowhead Tools is the largest automation and digitalization engineering project in the EU. It has 88 partners. It includes a lot of big players from the Excel and from Artemis associations. Earlier, it has been Productive 4.0, which included even more partners. Infineon was the leader, and BMW, Volvo, AVL, and XP Philips, all these big players were there. So the Arrowhead story actually started around 2015 or something, and before that there were some foundational projects that showed the way to Arrowhead, and the Arrowhead project was actually a very special one. It lasted 4 years actively, and then the results were taken up by various others like C Square, Mantis, and then Productive 4.0, Far Edge, MediHage, and now Arrowhead Tools is kind of completing everything in the engineering tool chain. And during this time, the technology readiness level has been improving, increasing, and now we are with some systems at the TRL 7+ level, which means that we have live demonstrators. So the motivations and how Arrowhead is different than other IoT frameworks. So the value is shifting across the cyber-physical value chain Today, the value is concentrated 75% so-called upstream in the electronic components, the boards, packages, the standalone embedded and electronic systems. But the value is changing. So by 2025, it is expected that 2/3 of the value will be captured downstream, meaning that we are arriving to the ocean of possibilities downstream. System of systems solutions are there, and this is where Arrowhead comes to play, both industrial and society domains, cyber-physical systems, and system of systems. So as you can see here on the middle right-hand side, the values are getting 10 times larger. The EU share is about 25–30%, so it's a great potential in this field, of course. And the Arrowhead project actually addresses the critical industrial requirements, such as interoperability, so systems have to work with each other and have to be interchangeable from each other. The real-time data in industrial systems, especially manufacturing, production, but we can count autonomous cars in here as well, why not? Scalability from small to great, security issues should be addressed, machine-to-machine business transactions, solution engineering should be efficient, which means that we are dealing with large systems and the combination of large systems of systems. So when you are deploying such a large system of systems, there are various vendors are playing, there are various stakeholders on the site, and these complex systems should be engineered, deployed, operated efficiently. So we have to make it easier. We have to decompose these system of systems. We have to make it easier and standard to do this engineering. And we can start with model-based engineering, but definitely it helps if the software, as many as possible, is open source, so people can reuse each other things and know what's really going on. The Arrowhead Framework core infrastructure is open source. Of course, it's available for everyone. So the motivations behind Arrowhead is that there are various cyber-physical systems and industrial IoT systems that are developed all around, but the developers and integrators use great variety of tools, as I said. And they have lots of legacy, internal interfaces, communication patterns, and it's really hard to get these systems work with each other. Of course, we are engineers, so we manage to get them work together, but it's not straightforward. It should be more straightforward. Look at, for example, networking itself, or the internet applications themselves. They have quite standardized methods, communication patterns, and even design patterns. So when a newcomer comes into a networking system, it's very easy for them to get plug and play and networking nodes and equipments into operation. It should be the same for cyber-physical systems. It should be the same for industrial IoT systems. Or if not the same, but that's one of the paths that the benefits should be taken seriously there. Because for non-monolithic system of systems, there are different vendors. They have to work together. They're using different communication standards. They should use some similar standards that make sense, and common methodologies. So here, where actually Arrowhead differs from all the any other IoT frameworks, because it is from the conceiving thought, it is based on service-oriented architecture, which means that all the information exchanged between anyone is thought that it is a service. So this information exchange is a service. There are service producers and there are service consumers. And we have to describe those services, the semantics of it, of course, the communication profiles of it. But everything is taught in an abstract level as a service. And we are looking for service producers. This is a very similar idea that, like in the internet, when you are interested in news, you just type in CNN.com and the web page comes to you. The service comes to you. You don't have to know anything about IP networks, anything about the IP address of CNN. You don't actually know which CNN proxy or site or server that is closer to you will provide the web page for you. Okay, there could be several providers, systems that have the same service producing, and you as a service consumer get match-made behind the scenes to that service producer. So why use service registry and orchestration? It is because then systems become discoverable. It is very similar that you use the DNS service, the domain name service, for changing between service names and or web page names, let's say, server names to IP addresses. Very similarly, you have to discover what are the available services around. One service could be vibration sensor, giving a service to whoever is subscribed to that, or it could be a data analytical service, a special one for cluster analysis. That could be another service that you are looking for, and you are looking for producers of those. So these have to be, of course, security supported. So Arrowhead has strong security, and the overall aim is that we need minimal or no configuration from the user side. So not from the operator, but from the user side. How is it different then from all these other architectures and platforms? There are lots of differentiations. Definitely the service-oriented architecture is one of them, and that the Arrowhead defines the local automation clouds. But there are others, such as Arrowhead practically supports all communication protocols, because on the user plane, when systems directly exchange their data, they can talk any protocol, their own protocols, even legacy protocols. Only thing is that they have to have some sort of communication forms to the Arrowhead core services to make themselves discoverable, make themselves register in the service registry, or make sure that that communication will be secure. So these basic things that Arrowhead definitely provides, among other things. So the communication protocols towards these include HTTP, CoAP, MQTT, OPC-UA, and some others. Okay, so these are the main differentiators. The basic principles of Arrowhead. Let me see if there are any Q&A questions. There's none. If you have any questions, please type it in. So the three I's is interoperability, integrability, and independence. So Arrowhead interoperability is reached through many things, but the basics are laid down in the service-oriented architecture, where there are late binding of the communicating parties, the loose coupling of the communicating parties, and there is a lookup service where service consumers can look up or can ask for a service to look it up for themselves, where the proper service is provided or produced by someone else. Integrability is one very specific thing about Arrowhead as well, because it deals with legacy systems. So it's not just you have to come born with Arrowhead capabilities. It's not like that. We have adapters, software and hardware adapters for various protocols. We have even translators between protocols. So you can come and integrate your system into other system of systems in which Arrowhead plays a role. And Arrowhead is independent from underlying technologies, services, and from protocols from translation. So it's really a framework that has a lot of independence. One of the interesting ideas about Arrowhead is this definition of local clouds, because instead of sending up everything to the platform level to some global cloud, doesn't help you in real-time operation. There could be problems, issues with security, and of course, engineering complexity remains high with global clouds, whereas with local clouds, where you have geographically closed systems or security-wise similar contextual systems, or you have other logical combination between the systems, then you put them into one local cloud so they can communicate with each other real time or high security, or as the engineering complexity is reduced. And in between these local clouds, there are ways to exchange data securely and safely. We call these intercloud service exchange. So this is a really great idea about Arrowhead. The service-oriented approach, you have service producers and service consumers, and the service could be anything. It has a description, SD stands for service description, SD, and the service description is independent from the protocols, independent from the semantics. But the service description could have many interface design descriptions, IDDs, which have communication profiles and semantic profiles. So the service description have many interface design descriptions, and when the consumer look for a given service, it is checked for them if there's a producer talking in the same IDD matching for them, okay? Because there are lots of protocols, and you have to make sure that not even the underlying level 1, 2, 3 protocols are matching, but framework protocols, security protocols, and the semantics even should match in the application. So interoperability is really a challenge. It's really a challenge. You have to orchestrate the services provided and consumed properly, so the service consumers really get the proper semantics. In order to reach that, we have provided some rules for designers and users and testers and everybody in the value chain. This is actually in the tool chain as well. So anybody who works with Arrowhead systems can see the service description, what service provides or consumes, and there are interface design descriptions that include the communication profile, how the protocol looks like, how the security looks like, and the semantic profile, how data is described or how the protocol is described. And these IDDs could have many semantic profiles, for example. And when you put together system of systems come together by many systems. So systems have services, and system of systems have systems. This is the hierarchy. You can see the right-hand side is kind of the white box design, the design descriptions, and the middle, the black box, you can only see the building blocks, but not how they made. And this is the documentation structure for Arrowhead systems. And then you can pick and choose from catalogs, from these document catalogs. The services, you have technology independent services, and then you have to choose your technology dependent IDDs and communication profiles. Okay. So this is what makes Arrowhead in a way technology independent, that it talks in services and service definition and descriptions, and then of course underlying services check semantic compatibility and communication compatibility. There are some core systems in Arrowhead. The mandatory core systems, you have seen in the local clouds that there are some core systems. These three ones are the mandatory core system. Service registry, where the service provider, the producer of the services, register themselves with the services. The orchestrator, where the service consumer comes for asking who should I talk to, who has this service, so the orchestrator tries to find it out. And the authorization, which is a commonized name for AAA, authentication, authorization, and accounting, and some other security services as well. And if you can read, service registry starts with an S, orchestrator starts with an O, authorization starts with an A, so SOA. Haha, this is like service-oriented architecture, at least on the level of abbreviations. We have also supporting core services. So why Arrowhead provides supporting core services? When we designed the first systems and services for Arrowhead, and remember there were already like 80 partners in there, all sorts of different application domains, we found that many partners create similar things and don't reuse them. They just reuse them within the company maybe, and partners cannot, they are not able to reuse these systems like common software. They should. Why everybody writes their own event handler? Why everybody writes their own logger? Why everybody writes their own QS manager, for example, or translators? They can do that if they want so, but Arrowhead actually provides native systems for these services. Okay, we go into detail of some of these. Gatekeeper and gateway, you can think that these are, and you're right, and these are for inter-cloud communication between local clouds. For example, the workflow choreographer and the executor are for workflows, controlling workflows. You could have other workflow managers, but Arrowhead provides you some of these as well. So how orchestration is done is the application systems come with a request. This is a consumer, this gray one. Comes with a request to the orchestrator, hey, I want to get temperature service from this room. And the orchestrator says, okay, I try to get it from you, either from the orchestration store directly, or I check the service registry if there's someone just registered for this service. And I could even give this back to you if I want. Hey, this is your matchmate. But in that case, you as a consumer have to go to that guy and check for security if you're allowed to go in, and check for various semantics or QS if this guy is, if this provider is proper for you. And if it's not proper, you should come back to the orchestrator again, checking for others. So it's not good, because the application system keeps asking the orchestrator, give me one, give me one, give me one, and then it burns resources for checking them the security or checking them QoS. So instead of that, Arrowhead plays this for you and check if you are matching with security, and check if your QoS demands will be guaranteed, things like that. And if these are fine, the orchestrator then gives you back, here is the service producer for that, and here is some, for example, timed token for security reasons, for authorization reasons. for 1 hour you can use this service, as an example. But if there are no service providers in the local cloud, and you as a consumer said that it's okay if you find it in the Intercloud, the gatekeeper checks in other local clouds if there are matching services. So there is this global service discovery and intercloud orchestration behind as well. I already said that integration is an important piece for Arrowhead. So interoperability is provided by, if you are not a native Arrowhead system, then you could have software adapters in level 2 or hardware adapters in level 1. We already provide various software adapters and hardware adapters. Hardware adapters, you can imagine like digital protocols on one side, like SPI or I2 or whatever. And then these digital protocols get translated into some co-op or some MQTT messages on the other side, or you can digitally talk to your peers in your own low-level protocol, but you are Arrowhead discoverable. So this adapter makes you Arrowhead discoverable. It looks like that you are talking and you are registering in the service registry, or you are getting orchestration as an otherwise kind of dummy system that only knows one protocol. This is an example of such a local cloud where you have sensors, you have actuators, you have management tools, you have dashboards, you have algorithms that provide services, of course. You have adapters, hardware adapters to comply with communication standards towards the service registry, orchestrator, or the authorization as the core systems. Okay. And then the intercloud orchestration process, I don't show you completely, but what it actually looks like, that the control plane is gone over the gatekeepers, whereas when they say that, okay, this is your application system providing the service, then the data flow actually then goes through fast switches and relays only between you. So it doesn't go through any proprietary thing, but they provide high-level security as well into the cloud, because you need in here make sure that your message don't get hijacked in the Intercloud. Let me see if there's any questions so far. No, please put it in the Q&A if you have any. Or at least I don't see. So what are the support for the whole ecosystem, the value chain perspective? Let me give you the value chain perspective for this. In here, Arrowhead systems and services are not only provided on the manufacturing floor, down there on the edge level. That was, of course, the first thing, that we equipped sensors and actuators on the floor level with Arrowhead compatibility, so they are discoverable within their local cloud, within the manufacturing floor. And there are some loggers, there are some human-machine interfaces and edge-level algorithms to give you some local results. But you would be interested in higher intelligence. When you send your data, you share your data with others. For example, your platform level, your IoT platform level, where there are data lakes, there are stream processing algorithms overlooking many sites, for example. There are business intelligence dashboards, batch processing algorithms, all these with high capacity algorithms, and I mean high capacity cloud infrastructure that's running these algorithms. And then one level high up in the Industry 4.0 levels, you have the enterprise level, where you have enterprise resource planning or logistics planning and things like that, big overview. And in here, your data gets shared as well. So with this distributed architecture and with these hierarchies, we made sure that data gets securely there where it is supposed to, and players can really subscribe to data, for example. There's a question on the terminology from Kuhn. I try to answer. So it says that CPS can be combined into system of systems. Yes. If such a system of systems, a CPS in itself or not? Yes, there are. There is this question on cyber-physical system of systems and cyber-physical systems. This is a very interesting question, and yes, in here I'm talking about cyber-physical system of systems in these diagrams, but I don't always tell that these are CPS OSs. But yes, these cyber-physical systems can get together in system of systems. How to or where to chop the definition or the distinction, I think it's a little bit over this presentation, but you can put the distinction of where a cyber physical system ends and where it becomes a system of systems. There are debates, actually actual debates on this, even in Excel. Platform level means cloud level. Yes, it means the global cloud level. That was another question, because remember, we have these local clouds anyway, and these are all clouds in our nomenclature. So IoT platform, IoT clouds, yes. And how the supply chain comes together is that all players or stakeholders have their own local clouds on the manufacturing floor, on the distributor, and on the ERP systems and platform level and enterprise level, or they could have a site level clouds as well. It depends on how you want to define your clouds based on real-time security or other contextual, logical way that it makes sense. And then these talk to each other, and this is through services. So it's, services get exchanged, information get exchanged among these services in the way that you can see in here. Of course, these are not talking the same protocol always, and that's why we introduced the translation service in Arrowhead, and it works already between many protocols, where the consumer is looking for a given service, but it is only provided, like this service is only provided by the service producer in co-op, but the consumer wants to get it in RESTful HTTP. So there's a translator where the translator translates between co-op and RESTful HTTP protocol-wise, but the data itself, of course, remains untouched. On the top, you could see one possibility. For example, an OPC-UA consumer and producer wants to get registered or get orchestrated through Arrowhead. So it has to have an OPC-UA translator, because Arrowhead originally only had HTTP interfaces for everybody. So you should have a translator. But now, and this is what we keep doing with all different sort of protocols, now this OPC-UA consumer producer doesn't have to have any translator, it doesn't have to have any HTTP, because now we have an OPC-UA, a native interface in the core systems. So the OPC consumer producer can talk directly to a service registry or the orchestrator or the authorizer. Another thing on the value chain, this is a production example that Arrowhead has workflow managers and workflow choreographers helping the production. Because remember, the orchestrator only says, oh, I need this service, here is this service provider. Oh, I need a service provider for this, here is one. But this is really ad hoc. It doesn't have a workflow for the orchestrator. It's just a request response kind of once of a kind thing. But if you have a workflow, if you have a recipe how to do things, then the workflow choreographer has this recipe of step by step what to do, after what to do, after what to do, after what to do. And then because of late binding and loose coupling, these systems maybe are not directly bound, communicated to each other. So at each step, the orchestrator, it asks for orchestration. At each step, it asks the orchestrator what should be the proper service provider for this service, for this system. And then it happens to that robot has to do that, or that nut runner has to do that, or we need that sensor data, or we need that camera from there, because it has clear resources, and it is part of the planned description. And of course, many times we do the same things, but if we need to change a plan because of lot size 1 manufacturing, for example, or because of reshuffling the plan every day, then it is a lot of human work, so to say, to wire together everything that now this is the way how you work together. Instead of that, the workflow choreography does it for you real time, dynamically, even after one new production. You create one track this way with these tools, and then you create another track with this way, those tools, because it has extra functionalities. Okay, so this is workflow choreography for you. And we have other supporting core system features. As I said, we have the translator, we have onboarding controllers when the device is waking up and getting into the local cloud. We have this workflow choreography for workflows. We have the plan description for describing manufacturing plant and what are the status of the different systems in there. And event handler, US manager, certificate authority, and so on. When talk about ecosystems, I cannot not talk about the blockchains and smart contracts, because we cover partially these as well in Arrowhead, not fully openly, but in private blockchains between interested parties of the ecosystem, because it is fast, it is secure, safe, trusted, validated, immutable, you cannot change anything. So at every transaction, every information exchange, I can write it on the blockchain that I given you air quality measurement. I given you an accuracy measurement. I given you an accuracy measurement every second, and so at the end of the year you can pay for that. Altogether, we just count what is on the blockchain. So all these real-time operations, security, safety, high reliability, all these requirements that are there for industrial IoT, we managed to address in Arrowhead through blockchains as well. So we have that kind of perspective as well. It's not necessary, but it is an option. So the last part, support for the whole ecosystem as a toolchain perspective. Maybe there were some questions, but there were no questions at the time. Please type it in the Q&A. So there is an engineering gap still. On one side, we have the legacy automation engineering tools, and they are used in whatever ways it's working. It's really good. But on the other hand, we have all these really flexible, robust, also proven, secure, working IT infrastructures and ideas and methods, and IoT and system automation solutions, the digitalization solutions. But maybe there are no tools, no design time tools for that to have, no testing, no operational and maintenance tools. So we need to grow an ecosystem of tool providers around Arrowhead as well. And that is what Arrowhead Tools project is doing. We need integration platforms, lots of things, and we need demonstration pilots. So these tools around the Arrowhead core technologies, what I already told you, this is what the tool project is for. So the engineering toolchain is originally have 5 or 6 steps, from requirements to operation management and maintenance, but we extended this with a little bit of different meanings here and there, and we extended with evolution. So we have a feedback loop practically to each of these boxes, and we have a training and education. And what's interesting in here, in these service-oriented architecture diagrams or connectors, that this is also meaning that tools can be on the fly orchestrated, design time or runtime orchestrated, and that information flow shouldn't be typed from one stage to another by a person, because I have one tool that has this structure output and then I need to input it in another tool. Actually, Arrowhead Tools addresses that by making automated information exchange between these phases, between the actual physical tools. Okay, so we support that as well. An example of that, requirements are coming usually in human readable or human explainable forms. It's very hard to make, for example, system models or functional designs based on Word files automatically, so it's not that, but there are some things that you can do still. For example, we have modeling tools, system modeling tools in Magic Draw as part of the functional design, which already automatically getting sucked up by catalogs. We're working on getting it to Eclipse Warto automatically, so it makes catalogs do that. And then actually the modeling gets automatically into an Arrowhead management tool, and it will get into plan descriptions and configurations, so you don't have to manually type them in. It gets into the management tool, so from the model you have the cloud infrastructure, the local cloud. For that we have the representation of each physical equipment. The operation and management is done by the Arrowhead core systems. The maintenance is provided by other things, for example, the Mantis architecture, which is for proactive maintenance. Evolution provides a feedback loop, and the training and education material can be created from all these descriptions up there. And just in the Arrowhead tools are 21, 25, I cannot count anymore, commercially motivated use cases. So it is not just the technology that we are building, we are actually trying it out and demonstrating it through use cases that are actual problems in the field, and they want to solve it. And they're going to solve it through Arrowhead with Arrowhead Tools. Just to give you a glance, Arrowhead is at version 4.2, and we are working for 4.3 and version 5. But it is not only the local cloud properties down there, the main and some supporting things. We have secure infrastructure. We have things for interoperability, translating between OPC UA 61499, Fiverr, Basics, Modbus TCP, ROS, all those things. We have system of system support. Lots of Eclipse projects are joining us, including Hono, Capua, Cura, Hawkbit. We have control support, execution support, as I told you, supply chain and product lifecycle management, and engineering tools, of course. So part of those engineering tools, again, Eclipse tools. So this is keeps changing. And we have already active interaction with many Eclipse projects, including Fordiac, Water, Hawkbit, Ditto, Ono, Paho, Mosquito, and Cuxa. And more and more are coming in. We are making interfaces with Capua, Cura, Leshan, Wakama, Keti, Milo, Unide, OM2M basis, and a lot of others. So when these Eclipse projects come to play as well, they have overlapping features with Arrowhead. But this is not a problem. Nobody has overlapping features with Arrowhead's local cloud infrastructure and the service-oriented architecture. But there are some device management, there are some M2M, machine-to-machine communication management, there are some digital twin state management, things like that. That all add to the Arrowhead application systems. So thank you very much. This is what I wanted to say in short about the industrial ecosystems of Arrowhead in the value chain and in the tool chain perspective. And you can find resources on the web, on the Arrowhead framework web, in the Eclipse Arrowhead project as well. You can find all release source codes on these previously showed systems in GitHub. You have the Arrowhead book, IoT Automation, the Arrowhead Framework. We have Slack channels, we have lots of other communication channels. If you are interested, drop us an email or get in touch with us. Okay, so thank you very much for your attention, and there are some time for Q&A, I think. So thank you very much. Any questions? There are some questions in the chat window I can see. There were, two questions in the Q&A which I already answered, I think. One was about the CPS and CPSOS, where the distinction of CPSOS is based on definition, and really there are intensive talks about this in various platforms, including Excel and probably HiPEAC as well. So all in all, thank you very much for your attention then, and please check out our website and get in touch with us if you want to use the Arrowhead framework. It's really useful. At the moment, in the Arrowhead channels, there are 140 users, actual physical people who are using, experimenting with, or getting into products, the Arrowhead. So this is not a small number. We are in daily support with them. So please join the initiative. Thank you very much. Thank you very much.